Here at Fruitland, we make things, but what we make best is our line of rotary vane vacuum pumps. In this episode, let's get into what a rotary vane vacuum pump is. So first, what is a vacuum pump? Well, if you know what a vacuum cleaner is, you're already about halfway there. Vacuum cleaners and vacuum pumps both move air by displacing it. They both create push and pull at the same time, and they both are designed to suck things up into a tank or a bag. So what's the difference? Well, for starters, vacuum cleaners are designed specifically just to move air and don't necessarily try to get good vacuum or HG. This means that air movement, measured in CFM, is very important for a vacuum cleaner, whereas a vacuum pump is designed to maintain vacuum conditions in a tank or a vessel under much larger or heavier loads. This means that a vacuum pump has much more push and pull power. It pretty much all boils down to HG and CFM. The CFM and HG of a vacuum system, whether it's a vacuum cleaner or a huge vacuum truck, can be manipulated by a number of factors like tank size, orifice type, horsepower of the motor or drive being used, and the reach or the depth of the hose being used.
A small rotary vane vacuum pump that we would design for a porta potty truck,
right?
A truck that does Johnny on the spots, is typically a 2 or 3 inch pump pulling down anywhere from as small as 70 CFM and usually tapping out around 250.
Right. To put this in perspective, a higher end vacuum cleaner can move air at around 80 CFM and can pull about 7 HG of mercury, whereas our mid-range flagship pump, the RCF 500, can move 338 CFM and maintain 28.5 inches of mercury. And just to brag a bit, our largest pump, the RCF 1200, can move air at 716 CFM and also maintain 28.5 inches of mercury.
Allows. So 29.92 inches of mercury, as you say, is perfect vacuum, achieved at a laboratory, 65 degrees Fahrenheit,
right,
at sea level.
Right.
Well, we don't get that on our trucks. We just don't. That's done with vacuum boosters and in labs and stuff like that. So, but that 29 inches of mercury represents 29 feet of water. Whatever you can pull 1 inch of mercury, you can pull 1 foot of water.
Oh.
So in theory, we can only pull 29 feet of water straight up.
It gets very complicated very quickly when you start to drill down to the HG and the CFM and vacuum and how they're all related but all different at the same time. But the main takeaway here is that vacuum cleaners are designed to be strong air movers and vacuum pumps are designed to hold vacuum in a tank continually. So when we install a vacuum pump into a vacuum system with hoses, tanks, and orifices of many different sizes and styles, we can use the same pump in many different types of applications.
I mean, I've seen our Fruitland 1200 pull sewage from a digester at the Port Dalhousie treatment plant from 38 feet. It's liquid, it's a liquid vac, it's, you know, a smaller hose, but he's adding air to it. In fact, he adds compressed air. So with the suction hose, there's a 1 inch air hose that runs side by side with it, curls up into the end of the hose like a snorkel would, blowing air in. And so you got air and the sewage rising up that hose, and again, from 38 feet.
Fruitland vacuum pumps are used all over the world in conditions ranging from deserts to frozen tundra. Our pumps are the best for so many reasons, but the two most important ones are our people and our design. Join us in the next video to find out how rotary vane design makes our pump one of the best out there. Links, as always, are in the description down below. Don't forget to like and subscribe.